Good evening, all. This is Ashok Kumar, PMR scholar and teaching assistant of Sensor and Actuator of the NPTEL class for live discussions. So today we have discuss about in a class week, that is the last discussion class. So if you have any doubt from the week 1 to week 12 regarding any assignment or any topics, you can discuss here first. So we will take your first doubts. We will discuss about that problem, and then we will move forward to week 12. So in week 12, we will do the recent trend in biosensing and 3D printing. So last time we have studied that biosensors, flexible MEMS, phonotyping sensor, and CAD modeling regarding that last week 11. Now we have to in this week 12 we have that biosensor for ATM phonotyping of the breast cancer tissue for better progressive. So what is the stage of the cancers? How we can identify the breast cancer? What is the mammography? So we will discuss about regarding this some doubts. Then biosensor for electrothermal sensors. Then MEMS based sensor for cathodic contact force measurement, that is for the eye. Microfluidic based drug screening we have already discussed, but if you have any doubt, then we will discuss regarding that. Basic aspect of the 3D printing. What is the 3D printing? What will be required for 3D printing? How the device will be printed in the 3D machine regarding that. And basic 3D printing materials and demonstration of remote 3D printing, that ocean print we have discussed about that. Regarding that octoprint of the 3D remote platform print octoprint, how you can, this is the open access platform where can you design your things, and you can simulate it and design the 3D things there. Any sensors or 3D design in the mechanical form, MEMS form. So we will take first your doubts. If you have any doubts, then we'll be, unmute yourself and please doubt yourself. So Ashok, are you there? Ashok, I am audible.
Yes,
So
sir, you are audible.
have you any doubt? Anything?
Nothing, sir.
Anything
I was thought whether any MCQ discussion will be there for all the any important MCQ questions.
for exam?
Yes, yes,
So regarding an exam, any doubt? Anything, that have you submitted all the assignment?
yes,
That
sir.
so how was the experience of your quiz? It is difficult.
Only one difficulty we feel, sir.
What?
There is no lecture notes available because we go through lecture notes. It will be but easy for us preparation.
It is
As to,
available, ma'am.
no, only you are giving you only text transcripts.
Yeah, task with you can that's note type. They have written everything that what they have teach in that class.
Yes, but normally I have other courses. They will be giving that PPT as a PDF. It will be easy for us because when we go through, if we have any doubts, also we can raise it there.
But in my PPT, I have explained many things that in
Your things okay, sir. Normal. I'm talking about your. I've got your PPT, sir. Your sir's lecture.
even I
That
have all the PPT I have uploaded on that folder. That things.
yeah, I have seen that, sir. That is enough for me. Regarding, I'm talking about the whole courses. Doesn't have any week. Doesn't have any lecture materials.
Okay, okay. So we will inform to that coordinator of that faculty, that coordinator.
Yeah, because your lectures has been a bit clear because I have gone through it, so it is clear to me.
We will next time, maybe that this time not if this time available, they can upload you, they can share you. I will write to email to that faculty advisor.
Okay.
If they have, then they will provide you. Otherwise, in the next time we will include that things that either they have to upload some PDF basic things or some research paper for your reference.
That will be a bit enough for us, because
Yes, yes.
normally it will be difficult for us to follow you all the time with your videos. I have downloaded all your 11 PPTs, sir.
Actually, this subject is based on the research thing. So all the content are taken from the some research paper only. That
Okay, that's very good.
okay,
Thank you. Thank you for your help.
because these are only based on that for the PhD scholar or so, some MTech or BTech scholar who want to know about that how the fabrication that even that how CMOS will be fabricated or how that single diode will be fabricated. Okay,
Yes, sir. Right.
they have seen outside that this is the diode and they will be working, but at what
Yeah,
material they are.
normally that is correct because I too have only my mechanical. So I too have that issues. But after seeing that only we know this much mechanical components have been there inside of fabricating a sensor itself.
Even in a mechanical, people are working on the microfluidic type sensor. Many
Yeah,
mechanical
that time. Then
persons
only
are.
I came to know the opportunities available for mechanical engineers over there.
Yes, yes, because it is easy to design that microfluidic sensor. It is very easy for that other type of sensors, and if you use the different of the materials or substrate, and you can enhance that drugs or the efficiency of that microfluidic sensors.
Yes, sir.
So
Sure, sir.
yeah, even I have explained the 3 to 4 times that lithography, that positive, negative lift off. How can you that use utilize? In the lecture, they have not explained about that more about the silicon substrate. Even I have explained more about that how you identify the silicon substrate, what is the plans, and that everything that how to you even you are the more familiar about the AutoCAD and regarding that.
Yes, sir.
And now you are also familiar about the 3D printers that people are using that.
Yes, sir. Now also we have just to go through in the 3D printer also over here.
So you are even that people are can simulate that design 3D printing design on Octoprint that remotely that open access for the people also that how you do the modeling and jointing of that 3D things that so you have used some liquid solution or some Fevikwik type some solution to joint that a metallic joint of that materials. That jetting, you know about that metal jetting, what is metal jetting and that things.
No, sir. I have not. I have any idea about recording that.
So you are in the BTech or a PhD scholar?
I am faculty in an
Where?
engineering college, RMD Engineering College.
So you have completed MTech.
Yes, sir.
So in MTech you have, I mean, you have to maybe you have taken the lab of the AutoCAD things that how
That
the 3D view of the devices. If you see the front view, side view of the devices, how
yes,
it
sir.
will
That
you
and all
what
familiar
is
for me.
yes, yes, sir. So like that in the 3D printing machine, now it is around 25 lakh rupees that if you good things are easily available in the market, the 3D printing machine. In the
Yeah,
software like that
but
AutoCAD software,
still we have not used any 3D printers manually as the individual. We have just attended FDPs regarding like that only, but we have not used your 3D printers. Sir. So we have been yet aware to be or that.
okay, okay, okay. So Vishnu, so this whatever I have explained in the slide, it is more advanced than the faculty will be explained. So questions will be only the basic things about that things that they will be like that in the lithography that what is the difference between positive and negative lithography. Guys, 1 minute. Sorry for the interrupt. I have so we will discuss further that some doubts and so first question is the complete the following statement. The one statement is given to you is considered as the early stage of invasive breast cancer. So how can you at which stage you can identify that it is the early stage of the breast cancers? At which stage in the medical technology and medical terms, they have given that some stage that some technique they have for the sensor that uh, TMT staging system. They have TNM staging system. They have include that nomenclature by the doctors. So T means tumor, N means node, and N means meta means. So T means how large is the primary tumor in the breast, size of the breast. What are its biomarks? How the tissues biomarks will be reflected in the sensors. Node means the has the tumor spread to the lymph nodes. If so, where is the size and how many nodes are that spread and how many tissues will be there in the breast. Metastasis means has the cancer spread toward other parts of the body or not. It will be so according to that they have decide the stage that is stage 0, stage 1, stage 2, and stage 3. Even in stage 1 that is type of stage 1A, 1B, 1C. So according to medical terminology they have divided that. So can you anyone uh, answer the correct answer, which is the correct statement? So it is a stage 1 where we consider as the early stage of the invasive breast cancers. So what is the cancer staging? How can you identify that? What you mean by the cancer staging? So staging is a way of describing how extensive the breast cancer is. Means what is the level of the breast cancer, how it is dangerous, or at what level it will be spread in your body, including the size of the tumor, where it is spread to lymph nodes, whether it has a spread to the distinct part of the body, or what is its biomarks. So all the things will be defined through the cancer staging. Staging can be done either before or after patient undergoes surgery. So doctor can we mark your stage of the cancer types before surgery or after surgery according to his feelings and understanding. Okay. So staging done before surgery is called a clinical stage. Means before operating or surgery of your breast cancers, so it will be in the clinical stage, and after the surgery it will called a pathological stage. So clinical means OPD and that things that before that analysis he will be check out your history of that disease and everything, and clinical analysis will be done. In that stage, he will be called at clinical stage, and after that surgical, he will take some tissues or oh, Guys, please wait for 5 minutes. We will continue that. आपको बताना पड़ेगा कि इंडिया का इसमें लोकल कंटेंट कितना है। भले आप फॉरेन से मंगवा देंगे तो लगाओ, लेकिन इंडिया का लोकल कंटेंट वो तो जो हमने 20% लोकल कंटेंट इंडिया का है। सब जैम पे करो या चाहे बिड करो, किसी को भी कोई टेंडर नहीं होगा आपका। ऑनलाइन टेंडर आएगा उसमें भी आपको लोकल कंटेंट कंपलसरी कर दिया गवर्नमेंट। चाइनीज प्रोडक्ट नहीं होना चाहिए, सॉल्व है। वो कार्ड चाइनीज लगाते लेकिन पूरा प्रोडक्ट चाइनीज नहीं लगाते ना। आप जैम से चाइनीज प्रोडक्ट नहीं सकते, आपको जैम से सब बैन करते हैं। तभी तो पैसा कमाते हैं, सब्सक्रिप्शन दे रहे हैं। कंपनी को देते हैं, कंपनी की प्राइस देख लो, 1 लाख का लीजिए, बोलते हैं हम लाख रुपये दे देंगे। क्या कहते हैं, कंपनी की मदरबोर्ड हार्ड डिस्क सब निकाल लेते हैं, दूसरी कंपनी की लगा देते हैं। डिब्बा हुई है पहले 3 साल में ना, क्या करोगे गाड़ी वाला, क्या खराब होगा, कुछ खराब होगा 3 साल में, उनको पता है सिस्टम खराब नहीं होता। जो रैम वहाँ कंपनी 10,000 की दे रही है, वो कंपनी वही 4,000 में रैम लगाने हैं बाहर की लोकल की। बेईमानी कभी करनी नहीं चाहिए, धंधे में कभी बेईमानी नहीं है। जरूरी है, मतलब कि OEM मतलब कि ओरिजिनल इक्विपमेंट मैन्युफैक्चरिंग होती है, उसका सर्टिफिकेट, तभी आप बेच सकते हो। एग्जाम पे बहुत सी चीज़ें गवर्नमेंट टाइप कर रही है, क्योंकि अब गवर्नमेंट सब कुछ एग्जाम पे ही ला रही है। आपका गवर्नमेंट और सेंट्रल गवर्नमेंट का कोई भी इंस्टीट्यूट होगा, एग्जाम के बिना आप एग्जाम नहीं दे सकते। नहीं नहीं, ऐसा कुछ MNC देती है ना, जैसे जोधपुर में आपने ले लिया किसी का कंपनी का, तो मैं ये OEM ऑथराइज हूँ, उसमें आप वेरीफाई कर दिया OEM ने, कहा मैंने इसको ऑथराइज किया है, बस खत्म है, आप ही जैसे OEM सेलर वो होता है, ऐसा कुछ नहीं है। गवर्नमेंट अब बोले कि गवर्नमेंट, क्योंकि इसको मोदी को चलाना है, इसको पैसा कमाना है, 5% लेती है टर्न ओवर गवर्नमेंट GST के नाम। हाँ तो फिर वही है ना, तो गवर्नमेंट का पैसा गवर्नमेंट के पास जा रहा है, लोगों को प्लेटफॉर्म मिल गया, ट्रांसपेरेंसी हो गई, एग्जाम तो गवर्नमेंट की साइड से खरीदा, ऑडिट को दिक्कत नहीं। हम तो सोचते हैं एग्जाम को मिल जाना अच्छी बात है, ऑडिट को कौन सोचेगा, फिर ऑडिट वाले एग्जाम का रिजल्ट नहीं देते, एग्जाम से चलो फेंको बाहर, तो अपने 10 लाख का कोई इंक्वायरी नहीं, ऐसे खरीद लिया तो लोकल को कौन सा आवेदन किसको मिल गया, क्या किया ना, SAT अप्रूवल वो अप्रूवल, ये है उसको चाहते हैं एग्जाम को कोई घटिया फर्नीचर खरीदा, एग्जाम से खरीदा, कोई ऐसा फर्नीचर खरीदा एग्जाम से, एग्जाम का माल है, हाँ ये एग्जाम का माल है, 90,000 की पहले दी एग्जाम से, पत्ते का क्या पैसा है, 22 स्क्वायर फीट आता देना, जोधपुर से लेने के लिए इसको टूटा बना दिया पत्ते वाले, हाँ तो बस ये एग्जाम पे देखो। ये जुगाड़ से करवाया, ये तो था ही नहीं बीच में, ये बीच में एक पैर लगवाया, नहीं तो मैंने कहा टेबल गिर जाएगी, साले सपोर्ट कहाँ से आएगा इतनी लंबी टेबल पे, तो फिर इसका भी तेरा लोहा मजबूत नहीं है, तो बीच में बैंड नहीं करेगा, 3-4 साल बाद कोई बड़ा इंस्ट्रूमेंट लगा दे तो बैंड हो जाएगा, ये है। इसमें लाइन और दूसरी बननी पड़ेगी, हाँ तो इस तरह की लाइन इसमें वारंटी तो नहीं है, लोग बेच रहे लोग, ये है ड्रॉर के साथ में, हाँ सारे कुछ है नहीं, पता क्या का सामान नहीं है, ट्रांसपोर्ट बल्क ऑर्डर लिया 45 लाख रुपये का, क्या ट्रांसपोर्ट किया एक टेबल पे, हाँ ये 4 टेबल आई है, 4 इधर बहुत सारे लिफाफे का फर्नीचर आया, क्या महंगा है बता, 40,000 का फर्नीचर खरीदा, क्या ट्रांसपोर्ट कॉस्ट करेगा बता, तो फिर हाँ, ये है। एक बात देखो, मैं क्लास ले रहा हूँ, आप 219 के सामने पढ़ा है, फ्रैक्चर वाले आप वाले ही है वो, एक बार चेक तो करो प्रॉब्लम क्या है, हाँ ऊपर है, ऊपर 219 में ऐसी लैब उधर की तरफ थी ना, इस तरफ सीधे सीधे जाओगे ना, इस तरफ एक लैब है, नीचे 30 kb का 3 kb वाला पहले देख लो, उसमें क्या एक्टिव सप्लाई आ रहा है, नीचे मेरे पास कौन सा मल्टीपल मेरे पास नहीं होगा, वो लड़का भी नहीं होगा उस लैब में शायद, इसलिए मैं एक क्लास ले रहा हूँ। Sorry for interrupt. So we have discussed about that there are 5 stages of breast cancer. Stage 0, which is non-invasive ductal cancer in situ DSI, and stage 1 through 4, which are used to invasive breast cancers. So stage 0 will be for non-invasive, for stage 1 to stage 4 for the invasive breast cancer. The stage provide a common way of describe the cancer, so doctor can work together to plan the best treatment. So different doctors and domains are required for like neuro and ortho surgery. There people are required for anesthesia, so they can identify that which stage will be there, and they can decide a treatment according to. So stage 0 describe disease that only in the ducts of the breast tissue and has not spread to the surrounding tissue of the breast. It is also called a non-invasive or in situ cancer, TIS1N0M0. Okay, so only the ducts of the breast tissue will, only some parts of the tissue will be, it will not spread in the hereby and nearby of the cells and there, so only small part will be developing on that case. uh, Stage 1A, that first stage for stage 1, the tumor is small, invasive, and has not spread to the lymph nodes T1 and 0 M0. This is all the nodes are described by medical terminology. So you can do the Google and identify that what is the meaning of that. Okay. Stage 1B cancer has spread to the lymph nodes, and the cancer in the lymph node is larger than 0.2 mm but less than a 2 mm size. So tissue size should be that node size of that lymph node should be between the 0.2 mm to 2 mm size. That will be in the category of the 1B. There are either no evidence of the tumor in the breast, or the tumor in the breast is 20 mm or smaller, T0, T1, and 1, that they have the medical terminology. So stage second 1A, any one of these condition, if you are in the stage second 1A in the breast cancers, there is no evidence of the tumor in the breast, but the cancer has spread to 1 to 3 axillary lymph nodes. Means 3 to 4 nodes are there. Like that, these are the 1 minute. Mm, like that, this is the nodes of that, 3 to 4 nodes are there. So these are the nodes here. So they have connected that 1 to 3 nodes. So these are spread on the 3 to 4 nodes of the, that will be category of that. The tumor is a 20 mm or smaller, had a split to one and in the stage second A. In the stage second B, either of these conditions should be followed. The tumor is larger than a 20 mm size but not larger than 50 mm, and has a split to 1 to 3 mm axillary lymph nodes. Also, but size of the tumor will be different in case of that. In that it is only 20 mm, but it should be in the stage second B, it is 20 to 50 mm. The tumor is larger than the 50 mm but has not split to the axillary lymph node 3 to T3 and 0 M1 nodes. So all these are that in the type of the how to we have to assign the stage for the breast cancers. Stage third A, the tumor of any size of the, to split of 4 to 9 axillary lymph nodes, means it will be split around 9 nodes of that your breast cells, or internal mammary lymph nodes. It has not split to other parts of the body, means only that in lungs and anywhere, that it will not T0, T2, T3 is node size, and what is that M0, M1 is T0, means there is no evidence of the crunch in the breast cancers. T1, T2 is the tumor is larger than T3, the tumor is larger than 50 mm. T4 N0 is the either of the following node. The cancer is 1 to 2 to 3 is the nodes. It is metastasis M0. There is no evidence of the distinct metastasis. It's not last stage of that cancer. M0I plus, there is no clinical or radiological evidence of distinct metastasis. MN, there is evidence of the metastasis to another part of the body. So it is till the M0 stage. So in the stage second, third stage, and stage 4 is the metastasis. It will be also spread in the other parts of the body of the human being. So next question is the complete the following statement. Is the screening test of the breast disease? So primary screening test. What is the technique called the primary screening test of the breast cancers? So it is mammography. I think 1 minute. Sorry guys, some important call. Uh, so mammography is the technique which we use to screen the test of the breast cancers. I think Dr. Chandrasekhar will be know about that more about. Can you elaborate that? You have aware about that, doctor? Dr. Chandrasekhar.
Hello. Yeah. Yes.
So I think you have more knowledge about that mammography and with this all three technology.
Technology, I have no, literally, I don't have any idea about it. But
But it is
yes,
a medical terminology. This is even that you are more understanding about that. What is difference between electrodiography, computing tomography, and mammography?
yeah. That I can tell you. But the mammography, I think that is the uh, screening test done usually for the breast cancers. But more of mammo is to tell you about the it will give you the complete knowledge about how the tissue of the breast cells are. I mean, breast tissue, how it is, that will come to know with mammography.
So, have you practical experience of that reading? How you could analyze that data?
No, I have no idea about it, to be frank.
Okay, okay,
Mammography.
okay. So, have you seen that machine that how that they have to do testing of that in lab?
Yeah,
Mammography that.
I've seen, but I have no idea how it works actually.
Okay, okay, okay.
Usually,
Actually, this electrodiography and computing tomography is the advanced version when you in the stage that like that we have to assign the stage for the breast cancer like stage 1, stage 2, stage 3, stage
yeah.
0. So mammography will be done on the stage 1 that when it is a primary that doctor identify that its size is very small and tissue will be that breast tissue will be not in fact the lymph of the nodes of that breast then they will be do the mammography that identify that. But if you
Yeah.
it will be
That
it it will be spread in the body or it will be size of that about that 50 diameter then they do the electrodiography or computing tomography in that case. That is the advanced version of that, but for the primary screening for the clinical stage or in the after that surgery that pathology stage they have do the mammography. After that treatment of surgery of that and then they do the some pathology that stage will be done for that tissue will be removed or not then they will be the primary screening they will be mammography, but in the depth knowledge or depth screening they will be through the electrodiography or computed diagram tomography they have used.
Yeah, actually there'll be little micro calcifications will be there when there is starting of breast cancer. In
Yes,
such cases, so you can only see in the X-ray about the characteristics of masses,
yes,
not
yes,
of there are masses you can see there. Only that I know. Like in X-ray, normally you can see the small amount of calcification areas you can see.
Okay, okay. And doctor, I have go through your that paper, and then I will take 3 to 4 days, and I will reply you that briefly that.
That is okay, sir. Take your time. That's not an
No, no,
issue.
I am busy with some things, and whatever I have time getting, I will be reading, and then I will be that giving you the report that briefly about that what you.
Okay, no problem, sir. Take your time. No problem.
Okay.
Sir,
So
uh, you are working in which place actually?
I am in IIT Jodhpur.
Jodhpur. Okay.
That's all.
Now I think PhD they're apply called for, right?
Yeah, yeah. There is open for PhD that with the collaboration with the AIMS and that IIT Jodhpur. AIMS Jodhpur and IIT Jodhpur have the one course that MTech and PhD dual degree in the medical technology.
Yeah. I just gone through that. What you had told.
Yeah.
We can apply for. I think there are any
You
applications.
should, yeah, you should apply and maybe you go get that PhD in.
Mm-hmm.
There is we have the bioscience department also here. Bioscience, we have the chemical, chemistry, and electrical, and we have start the clean room facility also. Though you can maybe characterize your device and you can learn about that how their tissue will be see you that, and you can make your oven some even one recently one many dentists will be join here for the MTech and PhD program here. Hello, are you there, Dr. Chandra? Hello. So
Hello, sir.
yeah, I am audible.
Yeah. Tell me, sir.
You can search that some people are working on that. They are from that background from the medical. And they are doing a PhD MTech. You can contact to the LinkedIn and you can ask about the more about detail of the course, how it will be and helpful you that.
Okay, fine. Through
Okay.
LinkedIn. Okay.
Yeah, to LinkedIn and many people are on the LinkedIn and even you can email to the person also that personally that you are interested and they can guide you that regarding.
Okay, fine. Thank you.
Okay.
I'll do that.
So, mammograph is a specialization medical imaging that uses low dose of X-ray to examine the breast for the early detection of the cancers and other breast disease. It is used as both of diagnostic and screening tool. So, it is the primary. So, when doctor in the clinical stage, if they have assigned that it is stage 1 of your breast cancers, then they have suggested to do the mammography. So even intensity of that X-ray is very low in that case. So it will be not damage your tissue that the breast cancer tissue that are in the growing stage in that stage. Easily they can the intensity will that X-ray will be identify that which nodes and lymph size and size of that disease will be there that. So now the previously that in the people are using that analog mammography. Now the all the things will be in the come on a digital mammography. So you can check on the system also that in the digital form and your report will be seen in the image in the digital form with the different colors. So also called as a full field digital mammography FFDM, in which the X-ray film is replaced by the electronics that are convert X-ray into the mammography picture of the breast. So whatever that previously that people are using the one paper will become that X-ray paper will become. Your image will be printed on that X-ray paper, and after that doctor will be see the X-ray that yes this is the identify. But now the all the things will become in the digital form. That image will that analog images will be converted in the digital form. So there is a one in the electronics background people are more understanding that signals and systems digital imaging how the image will be converted that digital image will be converted and you see in the pixel form. So there is a lot of the signals and advanced signal system will be involved in these systems. So they converted that pixel in the form of the images and you will see that image in the form that. So these detectors converted the X-ray that passed through them into the electronic signals. They are sent to the computer. Then computer converted these electronic signals into the image forms. So lot of the sensor are involved in that case. That sensor will display that data into form of the images and can be displayed on the monitor and also stored for later use. So the doctor can be see anywhere that in their mobiles or their notepad, pad, iPad in the system. Then there is no need to that carry the hard form of that X-ray with the patient. So it will be easily accessible for patients and patient and doctor for that. So this is the digital mammography machines. Recently, the market people are using that things, image of that. So this is the X-ray tube. This is the compression plate, and this is the Kestrel plate where you can put the tissue here, and this will be compress your things here. That this will become down, and then X-ray will be fall on that tissue paper. So what type of the mammographs people are using? One as a screening mammograph to detect early breast cancer in women experiencing no symptoms. If people are feeling that there is no symptoms and nothing sign of that breast cancers, and a doctor think that maybe that chances of the breast cancer, then one as a screening mammography, second as a diagnostic mammography. Breast women express symptoms such as lump, pain, skin rippling, nipple discharge will be happen. Then second type of the diagnostic mammography will be used in that case. So according to experience and symptoms that analysis of the doctor about the history of their disease, he will be suggested that screening mammography and diagnostic mammography. So this is the difference between that screening mammography and diagnostic mammography. For asymptomatics, well known to detect unsubstructed lesion. Means if you have no sign of any disease sign that you're not aware that you have the breast cancer, then screening mammography will be done. In case of the diagnostic mammography, for diagnose the breast cancers or abnormality that may have been detected through the breast self exam. Means आपको लगता है कि समटाइम्स दैट कुछ जॉइंट्स और ब्रेस्ट में कुछ प्रॉब्लम हो रही है, इट विल बी टाइट, automatically there will be discharge of the nipple, some liquid forms. So that time the doctor will be suggested that should be go for the diagnostic mammography. So emphasize on the mass population screening to reduce overall motility and mobility. Emphasize is on the individual benefits. Uh, According to guidelines should be followed for target for women and more for new age symptoms. So these are all the differences. If you have to aware about that, what is the difference between the screening mammography and diagnostic mammography. So how the procedure will be work, that how the people doctor diagnostic center will be done that mammography. So during the mammograph, a patient's breast is placed on the flat support plate. Here you can place your breast here in this plate, support plate, that cassette plate. That is a support plate and compressed with a parallel plate called pedal. So this is the compressed with that pedal plate, this compressing plate. An X-ray machine produces a small burst of X-ray that pass through the breast to detect located on the opposite sides. The detector can either a photography film plate which capture the X-ray image on a film or solid state detector which transmit in electric signal. So this have the both the configurations. So if you need like that hard copy or soft copy, like the printer have the, if you want to scan your data and save your printer, you can save your image in the computer in the electronic form, or either you can put the paper of that X-ray paper and you can print your that image on the X-ray also that. So it have the both the options. The image produced called the mammograms. That the image produced through that mammography, that name of the image should be called a mammograms. So on a film mammogram, low density tissue such as fat appear translucent, that darker shade of gray approaching the background, where area of the dense tissue such as connecting granular tissue or tumorous appear whiter or any gray background. In the standard mammograph, both the top and side view are taken of the east breast, although extra view may be taken if the physician is concerned about a suspicious area of the breast. And adult approximate effective radiation dose of women should be that X-ray dose should be we have to apply 0.0 to 0.7 millis SV. The effective dose are typical value for the average size of adult, so it will be according to age of the adult. They have to apply the X-ray. The actual dose can vary substantially depending on the person's size, as well as the difference in the imaging practice. So see that this is the standard view of the mammograph, how that they will be taken. So see that they have to press that things. RCC, LCC, they have to press. RML, these are all the terminology that I have not more about that medical terminology about that. So this is the view that doctor want to take, that which view that for he want to take this view, and he want to everything that what is the upper side view at 45-degree angles or some angles. These are the they have taken that different image of that different angle. So this is the routine mammography project. Things that they have done. So this is the see that this is the RCC, this is the LCCC, RML or LML. So they have taken from every side of that image, that mammograph image. So why does the breast need to be compressed? Why we need to compress during the mammography? So compression hold the breast in place to minimize the blurring of the X-ray image that can be caused by the patient's motion. So we have to hold that, and so X-ray will be fall. It will be cross that breast, that image that, and there one side is the detector. So when the X-ray will be crossing that your skin or that breast cells, it will be that intensity, that what is the input intensity and what would the output intensity, both will be compared by the machines, electronics, that component. So if it will be same, means it will be clear, it will be there will be any obstacle in between that, or some dense tissue will be there, so it intensity will be absorbed by the some tissues, and less intensity will be passed out to side, and that will be give the image of that. There will be some dark image or some greenish size of image will be reflected in your mammography graph, that things. So if the to compress the noise, if there will, if your the patients will be move here and move, it will be not hold the breast on the same position. So X-ray will be deflected here and there, and you will be not get the accurate image of your breast. So that's why we need the compressed plate. So it will be hold on one position. The patient, if the patient will move, breast will be remain on the same position. It will be not move here and there by the movement of the patients. Patient, sorry. Sorry. So also compression event out of the shape of the breast, so the X-ray can travel through the shorter part to reach the detector. This reduces the radiation dose and improve the quality of the X-ray image. So if anyone asks you to that why we need the compressor plate, that is the answer that for you. In your exam or anything, that if they will be asked, then you have to answer that. So this is the C dash. Without compression image and with compression. So see that this is the blood image, because due to some noise and you have to not capture that blood image. Suppose that if you take the picture from your mobile, so sometimes if you move the mobiles here and there's like that position of the mobile move the, so you not get the clear image of the object. But if you hold the mobile with the some hand and then you take the click your image, it will be more quality than the if you move the mobile here and there. So same case will be here in that case of that mammograph. So what will the result look like? A radiologist will carefully examine a mammograph to search for highly dense region or area of the unusual configuration that look different from the normal tissues. So suppose that a normal tissue should be in the white color or black color or the pure green colors. When there will be some cancer tissue or cell in the lymph nodes, maybe some dark color will be happen, some light gray color will be, that color will be changed in that case. Like cancerous tumor, non-cancerous mass called a benign tumor, complex size will be there in that graph, mammograph. Radiologists look at the size, shape, and contrast of the abnormal region, all of which can detect the possibility of the cancers. So they also look for the teeny bits of the calcium called microcalcinification, while usually beginning sites of the microcalcium may occasionally signal that presence of the specific type of the cancer. So as you, Dr. Chandar, you are told that they use the calcination before that mammography, and maybe they use the after the calcination of that things, they identify that there some be the cancer tissue or not be there. So if a mammograph show one or more suspicious regions that are not definitive for cancer, the regulation may order additional mammograph view with or without additional magnification. The compressor they may order bios. So according to that mammograph, he will be make the decision. So other alternate may be referred for another type of the non-invasive imaging study. So electrodynamic or these other technique that are available, he can suggest that you can do that if he is not clear through the mammography. So this is the normal breast anatomy. So this is the RMLO view and this is the RCC view. See that you can see that cells and node and tissue will be all is the clear that. These are all things. So this is the one is the intercostal muscles, pectoralis, glandular tissue, nipple, all things they have examined these things that. This is the normal breast density. You can see that category A almost entirely fatty at 10% of the movement. This will be happen. Category B scattered area of the fibroglandular density 40% of movement. Category C heterogeneously dense 40% of movement. Category D extremely dense 10% of movement. So these are the fatness of that the tissue of that split of tissue will be sent. So most of the women are category in the B and C, and around 10% of the women around come into A and D category. So this is the various well-known shape and margin, mass shape and mass margins uh, of that tissues: round, oval, lobulated, irregular, architectural distortions, circular, obscured, microbiological. So these are the shape and mass margins. How the margin of the tissue, density of the tissue will be seen in your mammograph. This will be the actual size will be there. So this is the shape of that breast size, oval, round, and this is the lobulate shape of that woman. So typically beginning of that thing, skin calcinification will be done in that case. So milk of the calcination will be that rod like plasma masket, rim calcination, round shape. So these are the typically before scanning that image, after the calcination that image will be taken in that case. So this will be show you the size of that cell tissue rim calcification. All this imaging show that these are the white portion will be share that you can check that the beginning of your cancer tissue will be happening in that case. So through that mammography, you can identify that what type of the stage, at which stage the cancer will be, breast cancer will be there. So limitation of the mammograph, a false negative mammograph look like normal even. So maybe that some that equipment problem or that technical person will be not taken that proper image. So it will be like that normal, but even that there will be cancer will be present that. So a false positive mammograph look like abnormal even that there will be no cancer in the breast cancers. So overall scanning mammograph do not find about 1 in 5 breast cancers. So among the 5 cases, only 1 people will identify that proper identification that so ratio will be accuracy very less in that case. So women with dense breast have more false negative limitation of the mammograph. So if the women have the breast density is more that like that 40%, so maybe that negative means there will be cancer, but from the mammograph we cannot identify that there will be cancer. So we will go to the other technology to identify that breast tissue will be that cancer tissue will be present in the breast or not that in that case. So next question will be that 1 minute please. Next question is the gold and platinum integrated electrode have thin layer of the chromium or titanium deposit beneath the electrode. Why it is done? Like that, this is the substrate we have used, like the sensors, to deposit, to make the electrode for electrical contacts. These are, I have to make the electrical contacts, and I have measured from probe station or some source meter will be applied. So suppose that this is positive and negative. So in that bottom, first we have to deposit layer of the chrome or tin, titanium. So why we required, this is the, suppose that this is the gold or PT. So what will happen if we deposit only that gold and titanium, like that, without that chrome, and so adhesiveness with the substrate of the gold and titanium is very poor. It will be not properly adhesiveness. So if you touch that devices or anything, some scratches will be happen. In that case, it will be remove that gold and titanium from that surface. So your device will be damaged in that case. So for proper adhesiveness and good adhesiveness, so we have to deposit only that small thickness like the 10 nanometer or 30 nanometers of that chrome or titanium before deposition of the gold and PT. Okay, so to metal like PT for good addition to oxide and thin layer of chrome to improve that additional is the correct answers. So we these are metal will be formed in the if we, because the all the devices will be kept in the atmosphere conditions. We have to handle that portable should be the devices. So maybe that oxide will be formed in that case, and the oxide will be formed, and then it will be maybe corrosion type of the something with the water molecules. Corrosion will be formed on the device surface, and it will be damage that chrome or gold and PT electrode. So we use before that chrome and titanium. Hello? Yes, doctor.
No, this usually gold and platinum are actually noble metals, right?
Yes, yes.
Why the corrosion will occur? I mean, titanium, you
Some
are telling.
like that it will be corrosion like that structure. Like that water molecules will be there in that case on the gold and chrome. So it
Okay.
purity will be reduced in that case sometimes. Like that
Okay.
people are not use the 24 karat or something will be mixed in that case also there.
Uh-huh. Okay.
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 And the pure gold will be not adhesive. Even you have to not make with pure gold ornaments you cannot make with the pure gold.
So over the substrate, there are chances of oxide layer will be there.
Yes, over the substrate
Usually.
they have in between if any surface will be available, some oxide will be formed here.
Okay.
And
Uh-huh.
oxide will be formed, then interface will be disturbed here.
Okay. Okay.
So for proper adhesiveness and proper contact for that formations, we have to make some a very small thickness layer will be deposit of the chrome and titanium.
Okay.
So in uh, what is the full form is FDM in the 3D printing? So have you seen the 3D printing anywhere?
Yeah. Yeah. I just we have actually we use it in our dentistry actually 3D printing
Yeah, yeah,
for
anything design of the teeth
surgical
and everything.
surgical templates we do usually.
Okay, so what is the full form of the FDM in that case?
I think fuse deposition modeling.
Fuse deposition modeling. Okay, right. So what is that technology that fuse deposition modeling? What will be happen in that
Will
case?
be a thin film of nylon. This thing will be there. I mean, layer of either PLA or acrylic or some other materials where we use it for 3D printing, some 3D materials. So it will be in wire form. So that
Okay.
will be heated, and the layer by layer it will be deposited.
So how will you join that things?
Usually, mm, by UV rays or anything, we use UV or ion beam.
Yeah, so UV, UJIR or some like that conventional method will be, you know about that, what they use for that jointing for conventional things. Now the this is the advanced technology. People are inbuilt the UV modeling and that things, that jointing, metal jointing with the UV. they melt the metal in between that with the UV ray, and then the addition is will be between two parts will be take place that.
Okay. That
So this is the CAD model, and after that prototype from the 3D printing that you can see that what is the 3D printing. So they have the design in the CAD tools. You use the Octaprint also in that case. That is the open source for the student and everything. You can that is the remote modeling. You can access from the remote things that also that in the modeling of your devices or any model you can design and hello.
yeah, yeah. No, no. You can proceed.
Sorry. So 3D printing refers to a relatively new class of manufacturing method which quickly produce a physical prototype from the 3D CAD data. So like that now the in the Chinese China and other country they are from the 3D printing they are building the building the building of that they have the design the home in the 3D in the CAD tools, and they send a command to a 3D printing, and they use that material they have to fill in that, and like that proper home will be manufacturing the 3D printing. They require a big printing in that case, but now that even you that people are that acrylic sheet they are like that some chain structure, car type structures, or some monuments they are manufacturing through that 3D printing that also that in the market that available with the 3D printing they are manufacturing. 1 minute, I will take 5 minutes for you. Sorry, guys. So these are the 3D printing designs. These are the CAD model, and this is the slicing that model. They have to put that one by one, then stacking and pasting that more everything that one by one component they have pasting, and this is the physical prototype of the manufacturing that. So they have by parts they have manufacturing in the 3D printing, and they have the machine that one molding machine in which they have joined everything in the presence of the UV light or other things they have. So they have pasting that everything and then bake the sample there. So this is the 3D machine and printers size that available. One is small, big, and this is the portable. You can use on the lab for the small size manufacturing of the devices. So I think Dr. Chandrasekhar, you have the aware about any one thing machine you have to see in your lab or anywhere. Which you have that machine, Doctor? So these are the images of the 3D printing. Does not require any mold as a precursor to manufactures. You have to not any dye or you have to require before that printing that things. You have to just make your design in the CAD tools or Octoprint, and you have to just give the command to the 3D printers. It will automatically fabricated your device as per your design that. So these are the guns. I think these are the guns and the toys designs they are the used in the 3D printing that. So this is the 3D printing does not require any model as a precursor to manufacturers. So these are the remote designs they have manufacturing through the 3D printers. This remote. So multiple parts can be produced in the one cycle in the 3D printing. This is the 3D printings. 3D printing has been used successfully to make parts of the various size. This type of the parts they have to this small size, big size, and this very narrow size in the nanometer and micrometers. They have the printing in the 3D printing. These are the all the design they have manufacturing through the 3D printing. So this is the fuse deposition modeling. Yeah. So this is the nozzles, thermoplastic materials. They are the feed materials here. This is the heated extras. We have to heating that. We have to melt that 3D matting, and this is the printing that materials that will produce parts. This is the stage where that some ink will be that metal will be come and printing that things that. This is the rapid prototyping of the machines, diffuse deposition molding type of machines. So this is the foam-based materials. This is the build material spool support that materials to rotate that everything. Their support material filament here to heating that things. This is the parts. This is the parts support they have to provide, and this type of the metal will be rolled here and it will be injected here. This is the 3D printings, stereolithography, SLA. Another technique that through the lasers they are using. One is the fusion model, and there is a lasers there. So laser and scanner system and laser beam will be melt that things that acrylic sheet or that nylon and anything, and then according to the parts will be fabricated. This is the rapid prototyping of the things. Selective laser sintering's another techniques. This is the power jettings. So liquid adhesive supplies that will be used at melting, jetting, and power set. The exam of that. This is a Ravel oiler, and this is the inkjet printed parts and power beds, and these all are the equipments they have using that in that. This is a rapid prototype that laminated object manufacturing loam things. So rapid prototype technology use a 3D inkjet printing, laser engineering, net shipping, selective laser melting, and electron beam melting. So these are the all the rapid prototype of the things that people are using that. So these are the 3D printing that some head mask will be manufacturing through that. This is the touch and feel that they have Taj Mahal they have manufacturing through the 3D printing. Form, fit, and function that tires and the guns and everything that uh, seat of the cars they have manufacturing whole seats. helmet, wind tunnel testing, validation of the invention that something that sport types, pattern for the castings, molds for the castings, pattern is a ring that ornaments ring they have the manufacturing through the 3D printings. This is the application theory designs, direct toolings, reverse engineering that they have to done that biocomputer materials they have at skills and that's everything they have to medical implant by the 3D printings. They have the printing that bones of the humans being that will be inserted either in the brain and everything that will be 3D printing will be designed according to that size and the doctor will be give the size and 3D printing will be used for that design of the bone and anything that see that these are the bone especially in the medical technology they have the medical appliances. These are toys. So material option for the 3D printing material metallic plant, carbon steel, tool steel, SS, aluminum, copper, titanium, bronze, nickel, aluminum can be used. Polymer and polymer composite, ABS, nylon, polycarbonate, PP, epoxies, glass filled polyamide, window foam, polystyrene, other sand, ceramic, elastomers, tungsten, wax, starch, these are used. Like biocompatible material that degradable is carbonyl PCl, PPT, TCP, PCl, hydroxypipette, HA, TTCP, PMMA, TCP that will be used. So what is the fused deposition molding FDM? So these are the based on the polyester acid material PLA and acrylonitrile butadiene styrene ABS system. In case of that light sensitive region photopolymers, photolithography or stereolithography that in the last slide I have explained that I have the image will be mentioned about the stereolithograph DLP and other type of the printed materials. So this is the fused deposition modeling technology that any printer that adds material to the model by extruding a liquid layer. So this electrode will be that acrylic sheet and it will melt and it will become in the liquid form here on that case. So this is the polyacetic acid PLA type of the material. They are biodegradable, melts at lower temperatures, can use a cheaper printer and still good result. All this is the acrylonitrile, butylene, sterling, ABS type of the materials. These are the used to boxes type of that and in the toys people are using this technology. Lego plastic is strong and durable, handleable at high temperature, but it required high temperature to print. This is the light sensitive region, ultra high resolutions, expensive region. Printer are coming down in cost. Region is still expensive thought. So light sensitive region will be used, and you can see that they have to make the some gap in that material and different designs. So this is the DLP digital light printing. This is the stereolithography. They use a laser and movable mirror as the light source for the printing. So light source will be melted material printing. This is the selective. If you want to print on the selective patterns, they use the selective laser printing, mix PLA, ABS, nylon. These are all the techniques. So PLA mixes with the other stem mixes into plastics such as metal, fiber, chemical, particle, and etc. Metal means copper, brass, bronze, iron. Iron can be picked up with the magnet, can be trans carbon with the graphene added. It can conduct electricity, build circuit, wires, and etc. Carbon fiber can up to 20% carbon filter. Woods fiber mix it with the PLA plastic can be used. Glow in the dark, color changing, high impact polystyrene, polyvinyl alcohol, wax, acrylonitrile, PPP. These are the materials PLA mixer can be used in that case. So we will go some videos about the live instrument in that what we are using that things. So some are the images and video of that component. So I am very thankful to the Vikas who will be provide me some image on my colleagues who are working on the sensors, gas sensors. So I think that video will be, this is the video of that CVD. This is the atmospheric pressure CVD. So these are the useful for material depositions. So how will we handle that things that you can see that this is the 3 zones temperatures. We use the quartz glass tube here. This is the quartz, this is a 3 zone, 1, 2, 3 zones will be here. 1 minute. These are the 3 zones. This is the first zone, second zones, and third zones will be there. So you can put here some materials here, 2 materials, and you put the substrate, and these will be uh, flow will be there, and heating will be done at the temperatures. So the below is that the heater. We have to on that MCB and we put the temperature control will be there in that case. Next is the low pressure CVD. This is the 2 zone CVD we have used, and this we are the aluminum quartz tube here, and these are the temperature control. We have to put the set temperature here, and we have to on the MCB that on. This is the bubblers where we have to put the precursor or material which we want to deposit, and this is the mass flow controller MFC through which we have to flow the gas, and this is the chiller for the heating purpose, for cooling purpose, that tube. This is the thermal evaporation system for deposition of the gold, chrome, or any metal for evaporations we have used. So this is the main chamber where we have to hold the materials. This is the turbo pump. That below is the, this is the turbo pump we have used. This is the chambers. We have to vac and unvac here. We high pressure it will be remain. So loading and unloading of sample will be go through the this chamber through. So this is the chambers. This is the turbo pump for making the vacuum and the pressure of the 10 to minus 6 L. This is the pistons. So this is the E-beam and thermal board integrated here. This is the all the electronic component for operating that things that. This is the rotary pump below. This is the normal thermal evaporation system. So this is the load the chamber where can you put the sample in and out here. This is the rod for moving the sample. You can put the sample directly here. This is the all the on off and everything, the frequency. Here you can see that deposition rate of the samples. These are the transformer. These are the transformer which will be heating that metals and putting in the board. And through the transformer, we will increase the current, and then evaporation will be take place. Some metal will be melted around 70 ampere current, some will be 140 amperes. So depending upon the melting point of the metals, when evaporation will be start, we have to stop theirs. So this is a turbo will be on, all the component will be available here. This is a water pipe, that blue will be water pipe for the cooling of that thing, board and everything. This is a live thermal deposition system. How will be thermal deposition will be taken place? So this is the substrate materials, and this evaporation will be take place. You can see that metal will be evaporated in the red light. The material will be glow. This is the shutter. If you want to stop that evaporation, you can put shutter here. See that this evaporation will be take place in the red colors that. This is the rotator there. See that. This is the board. You have to pure material here, and then you see the sample rotator. You have to rotate, so uniformity will be deposited here. Guys. So this will be deposition take place through the thermal evaporation systems. Here you can check that 157 only the deposition current, and you can check the deposition rate here. These are the deposition rate. 0.13 the rate, and thickness will be monitoring. This is the thickness monitoring and everything. You can program here that you can fix the Z ratio of the materials and everything, and then after programming you can start it. This is the sputting system. So physical vapor deposition system, this is the sputting system we have. So this is the turbo side. For the high vacuum, we have to start the turbo here. So this is the shutter. We have to open the shutter for when we have to start. This is the rotary pump, oil bowl. This is the vacuum. You can see that my chamber will in a -6 AD vacuum. This is the load chamber. You have to take out the samples here and there. This is the MFC for the control the flow of the gas. See that how do you have to load and unload the samples here. So this is the magnetic rod to which you can, here you have to load the chip here. This is the sample holder, so you can put your sample holder here. This is the gun where you have to put your target, and these are starters. When you open the target, deposition will take place. If it is closed, then there will be no deposition here. This is the sample holder spitting. After deposition, see you that material will be deposited here. You can see that this is the silicon vapor SiSi2. How you load and unload a chamber. See that. So you have to load. You need to load a chamber. So we have. Now he start the vacuum to the load lock chamber. It is called LLC load lock chamber. Then you have to open that load lock LLC gate wall, and then you have to insert your sample in the sample holder in the sample holder. Rotator. You can see in the image that your pressure will be down. You open the load lock chamber here. See that it will be atmospheric pressure 1000. Now the pressure will be reduced. Now it will be given the -1 and -2. The dump vacuum will be created. We are now loading the sample. You can see that image how will we insert the sample in the sample holder, the sample rotator to that magnetic rod. Now he closed that load LLC lock gate wall. Now he open that turbo pump. He will start so that where chamber pressure will be go to the low pressure around 1 into 10 to the power -6 millibar. Now it is the gate wall in the side of the turbo, so it will be open. So this is the plasma created image that in the sputting that physical vapor deposition system. So see that it is a target. You have to give the RF power here, and you have to flow that inert gases like argon or nitrogen in the chamber. So this type of the plasma, when you have to start a deposit with some materials on the silicon substrate, sapphire substrate or quartz or glass, so you have to put the sample holder and you have to see that video, and this type of the plasma will be created here, and then plasma will be created, then deposition of the material will be start. So I have explained you that in the class 6 and 7 that how that sputtering will be worked. So this is the sputtering diagram. So this is the sample holder of my things. So this type of the material sensor you have to fabricate it. Sorry. You can see that image that. So this is the silicon substrate we have to take, and this is the layer of the material will be deposited on the silicon substrate through the sputtering. So this is the all the process of the loading the sample and creating the vacuum and everything in this video. So this is the gun. These two are the gun. We have the 4 guns. So these are the gun. This is the target. We have to insert in the target guns, and we have to open the shutters. Which material we have to deposit in that case. And this is the sample rotator. So it will be rotate uniformly. So your deposition will be taken uniformly, and thickness of the film will be uniform in that case. So this is the plasma, real plasma created in the sputtering chamber through the RF power supply. This is the aerosol gel technology, aerosol deposition under technology machine. So I have taken from the National Institute of Advanced Industrial Science and Technology of the Japan this video. So this is the aerosol deposition method. See that this will be vapor will be created here. So this is type of the deposition will be take place through the aerosol. So this is the deposition will be take place through the aerosol deposition method. This is the lithography image. This is the silicon vapor. Here handling through the tweezers. So you have to follow all the protocol of that using the clean room the materials there. This is the lithography that clean room machines that. One minute, I will open again. It has some problem. Give me 1 minute. So here holding the silicon vapor, you have to wear the gloves and everything. So it will be not impurity will be not be on the vapor of the silicon vapors. This is the clean room technology. How the people will be see that these all the equipment will be that yellow light and everything in the lithography. So this is the uh, this is the 6 inch vapor size. The size of the vapor is very high. That see that it is clean and everything. So you have to take the tweezer and hold the vapor. Otherwise, it will break and it will be from impurity will be added in your. This is the spin coaters, spin suck. You have to set the RPM and everything that in that case. This is the large scale production laboratory. So size of the vapor is very big, that 6 inch size. So you can fabricate many devices on the 6 inch vapors. This is the photoresist they have hold. Now they have to drop cast this photoresist.
The disc size is always uniform, or it is maintained the same disc size? Even
What?
small disc.
Yeah, you can
This.
use the small disc also.
Okay, okay.
So according to your vapor, you can use the small. It will be suck will be available that 3 to 4 type of suck will be provided by the spin coater company.
Okay. The what you have dropped, no, that is photoresist.
This is the photoresist.
Okay.
So now they have coated the photoresist on the silicon wafer.
Uh-huh.
Okay.
Mhm.
Now they do the baking,
Okay. Soft baking.
soft baking.
Okay.
Now they have put that this is the photolithography machine. They have put the vapor that this is the photo mask. This is the mask with the mask, not a mask, maskless. This is the mask photolithography. So they have to put the vapor here on that photo sample holder in the photolithography. Now they have to expose that UV light. That see that this machine will be that the lamp holder will become front. Now that exposing will be take place that pattern
Okay.
with UV light. It will be now done. Now they have taken out that vapor. Patterning will be done. Now they are developing that pattern. They start the fume mode. This is the developer they have used.
What is the developer they have used?
Maybe that acetone or it
Acetone.
depends upon the photoresist they use. See
Okay.
that this photoresist will be removed that.
Okay. They will remove the photoresist.
Now they have this deionized water. They have to they have to clean that everything. See that this type of the pattern they have transfer.
Okay.
Now they use the optical microscope to check that pattern that it is developed or not developed. That it is
Mm-hmm.
over or under age or whatever they have to check with the optical microscope.
Mm-hmm.
So this is they have used either IP or acetone to clean that impurity will be anything that they have to clean that to clean the vapor that. Video will be stuck. Sorry, Dr. Chandra, you want any have a doubt? Anything we can discuss?
No, this regarding this process of lithography itself, stereolithography,
Yeah,
lithography. Just I wanted, when you do this micro heater, usually
micro heater.
micro heater, something it will be placed over the sensors, right?
Yeah, you can
Particularly
fabricate through the lithography.
through lithography,
Yeah,
micro heaters.
yeah.
Okay, the stages for micro heater are different for.
You have the different design. According to you can in the mask you can design your micro heater.
Okay.
Okay, and
Mhm.
like that,
No,
like that.
if
This is my
we are
silicon.
using.
Like that, this is my silicon vapor. Okay.
Okay,
So
okay,
you want to heat that heating the so from either chrome or platinum you have to deposit that material and you have to design that heater like that design area. And then you
okay,
have to apply some voltage or some current here. So with the voltage and current that material will be heating and it will provide as a work as a heater.
okay.
So on the
Uh,
bottom you can on the surrounding you can design your heater.
okay, okay. Uh-huh.
Okay.
And how about the sensors for flexible sensor and that like MEMS you say, no?
Yeah.
No, for those this silicon wafers or any what difference we have actually
They have used a flexible substrate like polyamide, PMMA. Uh,
instead
yeah, instead
silicon.
of the silicon, they use the flexible substrate. Even they use the paper also, that printing paper also for cloth.
Okay.
Even they have to fabricate a device on the cloth,
Oh, 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 oh.
paper
Okay.
or whatever that flexible things. They if they are bending, there is no effect on the property of that sensor.
It should not have any proper effect on sensor.
Yes, yes.
Okay.
You have to fabricate the sensors. If you have to bending 3 times, 4 times, 10 times, in the different diameters, then your device will be remain there on that, and your device will be working on in that case also that.
Okay.
So that's why this is the flexible. So use the substrate, you use the flexible. Whatever the sensing material you use, the either organic or inorganic, depend upon use.
Okay. Uh-huh.
Okay.
Okay. And when this piezoelectric this is used, whenever we require.
Piezoelectric like that. If you want like that,
Kind of pressure
pressure
applied
sensor.
sensor. Okay.
Suppose that you want to design the pressure sensors, and you have not to. It will be in the active mode. When you have to press anything, it will be generated electrical form. So your material should be in the piezoelectric materials, which convert the mechanical force into the electrical energy. So it has
Okay.
some
Okay.
magnetic movement in their particle. With the pressures, their orientation of the atoms and molecule will be changed with the pressures of that anything.
Okay. Okay. Okay.
So this is the piezo means piezo is the type of the materials that they use that materials, and it will be have the effect of the piezoelectricity or piezo ferromagnetic or piezoelectricity effect will be there in that case.
Okay. Fine then. Okay.
So this is the next step they have to develop. This is the silicon vapor. Again, I think they have to drop cast and everything that. I think that. There's some problem, I think that. So they have coated the gold before on the silicon vapor before the photoresist. Now they use the photoresist here.
So negative photoresist and positive photoresist, how we will come to know? Like,
It's depend upon your applications where you want to pattern your devices. You can use the positive and negative both, but mostly people here use the positive photoresist.
positive photoresist.
Yeah, because negative will be done the negative side. Where will be the exposure will be there, it will be removed and unexposed area will be remain here.
Uh-huh.
So this is the thermal. See that this is the thermal system. This is a load log chamber where you have to load and unload your sample. See that he have loaded the sample in the sample holder. See, this is the Sam that he have checked that image of that. He developed that everything that developer under. He will clean with that IP and DI. So these are the how the lithography will be work. So all these are about these things. So this is the last class. So if you have any doubt, anything, we will discuss further something. Or very nice to interact with you, all of you who will be participant or will become on the live class. Uh, the doubt will be very genuine and good doubt they have you have to ask in the questions that live session class. I hope that I will be able to answer that your problem and that questions query as per my best way, whatever I have to include and what the facility will be provided me. So I have utilized that everything to explain that you. If you have anything, any feedback for me, for the class, for the course, you can provide in the feedback form. Even you can uh, say now to me also that in front of that, okay, sir, these things will be needed or improvement will be done. So I will be improve myself also, and I will also inform to the course instructor and NPL team regarding that also. Any doubt, anything?
No, it is fine interacting with you, Ashok. I'm very happy with the way you are conducting the courses.
So all these things from week to week 12 we have covered lot of things regarding the clean room, wafer of the fabrication process, biomedical equipment, biomedical diagnostics things, microfluidics, IR sensors, gas sensor, different type of the pressure sensor. What is the performance parameter of the sensors? What is what is the definition of sensor? What is the transducers? From the week 1 to week 12 we have converted covered the many topics and we have taken the doubts on that asked a question from that on the NPTEL team. Even they have also responding your email on that form that things that your doubt. So whatever the best efforts we have to do, we have done our best works to solve your problem either through that live session class, either a ask a questions forms, or either on the emails we have you have to send us, we have to respond on that things that you have to read that things and clarify your doubts. So anything, if you have anything, we will take the one extra class. If you need your doubt, you can post your doubt here. So I will request to the NPL team, if you need any extra class, we can taken one extra class before 29. I think your exam is on 30.
Yeah.
Is 30. So before 29, we can take one extra class if you need any special doubt, any special topic you want to understand from my side. I will prepare. If you will just drop a mail on the ask a question form, or you can send me on my
Regarding,
personal email ID.
regarding biomedical this thing devices, if you can take any class, if in case if it is possible.
Which biomedical type? Microfluidic or drugs or what type you want that?
Drugs thing.
Uh,
Um,
Even I have explained that how the drugs will be done one
Actually,
session.
I have not attended the live session. I don't know whether you have gone through those topics.
No, no, I have gone. I have include one research paper that how they have delivered the drugs and how they will be designed, and after that how they check the electrical property of the drugs they have inverted. You go through that video. If you have any doubt, you can drop the email to me that I
Okay,
will
then
take.
I'll check in that
It
this
is
thing
week
video.
8 or week 9 class. I think that week 8 or week 9 or week 7. In between that, I have include that two research article also, that in that I have mentioned that article numbers also.
Okay, fine. I'll go through, and if anything required, I'll get back to you.
Yeah, you can write to email to me that then I will